Okay, we have here today another interesting integral from the Columbia Integration Bee 2022. This one's problem 10. We have the integral of 1 over x squared plus x cubed dx. Okay, the first thing I'm thinking about is that we need to do something with this denominator, like probably factor it. So what I think I'm going to do is let's just factor out an x squared from this. So when I do that, we just have x squared times x plus 1. So let's do partial fractions on this, and we can use the cover-up method to get some of our values. Okay, so for partial fractions, notice that this is the repeat case. We don't need anything more than just constant terms here, but we had to add this x term because of the repeat case. But anyway, I'm going to use the cover-up method to get some values. So to start with, let's do this x plus 1. If I plug in a minus 1 here, what I can do is take the minus 1, plug it in here, and cover up the x plus 1 so that we're not dividing by 0. When I do that, we're going to have just 1 over 1. So when I plug that in, this is actually just going to give me 1 over 1, or 1, and that's going to be my c value because it corresponds to this x plus 1 term. And then we can do something similar here. We can take a 0, plug it into the x squared, okay, and plug it in here. We cover up the x squared because we don't want to divide by 0. We plug that in here again, we have 1 over 1. So that's going to give me a 1 here for my b term. So now I just need a value for a, and we can't really use the cover-up method here, but if I plug a 0 in, that's already what we did for our b term. So we need to use a different value. We use minus 1 here. So what I can do is just plug in, I can just set x equal to 1. And so when I do that and plug everything in, we're going to have a 1 squared here. This is going to be 1 plus 1, or 2. Then we're going to have a over 1, just plugging 1 in everywhere. Then here, we know our b value is 1, and then we're going to have a 1 squared here. And then this is going to be 1, this is going to be 1 plus 1, or 2 here. So then a little simplification. This here is just 1/2. And then cleaning everything up here, this is going to be a plus 1 plus a half. I can subtract a half on both sides, and we see a plus 1 equals 0, or we have our a value equal to minus 1. But now that we have our a, b, and c values, we can basically just integrate this thing and finish this off. Okay, so just taking what we found here, we end up with 3 pretty easy integrals. So let's just integrate these things. So this is going to be, this first one's going to be minus, from there, natural log absolute value x, plus this is going to be power rule. We can write this as, wow, that's a terrible arrow. Gee. So this is going to be, we can write this as x to the minus 2. Integrating that with the power rule is going to be minus 1 over x. And this last one's just going to be natural log absolute value of x plus 1. So all I need to do is just put a plus c on the end, and that's going to be it. Okay, I'd say it was a pretty quick problem considering we did partial fractions, because that usually slows you down quite a bit. So we'll stop it there. Thanks everyone for watching. Have a great day.